Okay, I'm back here with some live streaming on Assimilate Python from zero. So I'm going to keep going through the basic tutorials for Python and master the key concepts here. So I'm going to go ahead and just share my screen here to start with. Let's go ahead and get that started. Here we go. And I'm going to make this a little bit bigger. There we go. Looks pretty good. All right, so to start off with, I'm going to go to the repo that I've used before here, which is going to cover AWS. So I'm sorry, Python. So assimilate Python. Here we go. All right, so one of the things that's pretty cool about the GitHub experience here is that you can launch these code spaces, and it really is pretty amazing stuff here because you can actually get a fairly sophisticated system here running. So I think what I'm going to do is I'm going to change things a little bit, and I'm going to use a template that I've created previously. In fact, what I might even do is just create my own Python template. I think that would be a good thing to do for what I want to solve on this problem. So the way this works with GitHub is that you can create these templates that allow you to give other people example workflows. And what's nice is that you can actually do things like set up dev containers, which customize your environment. You can actually go through here and set up GitHub actions, et cetera, et cetera. So this is actually a GPU-based template, but it's so close to some of the things I'd want to do for Python. I'm going to use this template, and I'm going to actually create this called a Python template. So this will be my example, what I think people should use when they're programming with Python. So we'll say this is a Python template for GitHub spaces. And the idea here is that this will be a good example for other people to use. And I'll mention why in a second here. So the first thing that we do is I, again, copy from this other template I set up. And now I'm going to launch a new code space here that will be a pretty powerful code space. So notice how I can say new with options. We can go through here and I can pick a really powerful machine. I'm going to pick a CPU-based option here, 32 gigs of RAM, lots of storage, 16 core. And this will take a second to launch. And so while this is launching, I'm going to go back to this template here, and I'm going to set up something called pre-build. So I'm going to go to code spaces here, and I'm going to set up a pre-build. And the idea here is that this will allow us to basically have a very fast startup time for our project. Now, one of the things that we need to do, though, is I'm going to switch this over to like a regular branch. So I'm going to create a new branch, and I'm going to call this one main branch. And then what I'm going to do is I want to actually set this as the default branch. And I think I've done this before. Yeah, where I would just swap it and say most projects name the default branch, rename the GPU to, we could either, actually, that's actually not a bad idea. I could either rename it or I could switch to another branch. And so in this case, since I already have main, we can just do that. And I'm going to switch to the default branch here. So now that I've got this set up, I can go back to code spaces and I can say, look, I want you to set up a pre-build. So basically get everything running for me automatically every time I push a change to this. And this is nice. Got that thing set up. Now, this is probably still running, which it is. It's installing all kinds of software. So what I'm going to do is I'm going to actually clean this up quite a bit. So I'm going to change this template that other people can use to set up Python projects by deleting a lot of the machine learning stuff, because not everybody does machine learning, not everybody does data science. I'm going to more make it a generic template that actually should load very, very quickly. Let's see, is there anything else that we can do here to change things up? Well, I mean, while this thing's loading, because this will take a second to load, what I could do is I could also just clean up some of the stuff inside of here. So I don't want to, include some of these files here. So I'm going to go ahead and delete that. So it's what's kind of nice about the just the regular web browser here is you can actually clean up your repo without even launching a space. And so I'm going to go ahead and delete that. I can go ahead and delete some of these text files here, right? So I can continue to work even though this thing's loading and being slow. I can still build out this environment and get it all working. Great. And what else do I need to do? So Hugging Face, I also don't need any of that. I don't need TensorFlow, right? We can leave all that for the GPU template that I set up earlier. What else do we care about here? This one we don't care about, right? So again, this is kind of a nice idea when you're setting up templates is you don't even need to necessarily build stuff out inside of a code space like this. I can actually clean up a lot of stuff before I even get there. So I think the other thing I want to clean up is this utils directory, which again, this is all for kind of like machine learning stuff. So if I just click on it, I can just uh, delete it, right? So I can still be productive while I'm waiting for things to happen. And go through here, delete this. So I use this technique quite a bit when I'm developing, as I use whatever tools available at the time. And in this particular scenario, I can use the web browser to continue to make progress. Here we go. And go through here. So kind of nice to be able to clean up your repo without even being inside of it. There we go. And now for the directory, well, let me delete the directory. Yeah, I guess it just deleted itself, which is kind of interesting. And then and then Hugging Face as well. That's a good machine learning problem, but I don't need it for what I'm doing. So I'm going to go through here and I'm going to delete this. And then the other thing I should probably clean up as well is the imports, because there's a lot of packages that are slowing down the installation that I'm not going to need. So there we go. We got a pretty good repo here. And then as soon as that's still loading, the other thing I'll do is I'll look at the requirements right here, and I can just get rid of a lot of this stuff. So like this wheel thing, I don't think I need that. I would say this is probably what we care about. DevOps, we probably care about Fast API, but the rest of this stuff, probably not stuff we care about for most like software engineers, right? So this is just a base template. We want to keep it real tiny, and this is going to be a common set of things that I'll use. And then if I look at the make file, do I have any hard coded things here? Yeah, TensorFlow. We can get rid of that as well. We don't need to do anything with that. And then we have, I think that's it. I think this is a good, yeah, I think we're really in great shape for when this thing wakes up. Okay, it just woke up. So now what I can do is while it's loading, notice it's on the GPU branch, which is not the branch I want to stay on. So I'm gonna basically check out the main branch. So I'm gonna say get pull, and it should you notice that it pulled down the main branch, and then I'm gonna say get check out master or main here. There we go. And so now that we're in main, I also can clean up the README a little bit too. So like, for example, we don't need that because that's for another project. And we say template for Python projects. So I'm going to clean it up a little bit. Python projects. And yeah, all this should be good. This is all stuff I would care about. Most common Python libraries for, and we'll just change this for DevOps and software engineering. Or I shouldn't say most, let's say like a base set of libraries for DevOps and web. There we go. And then we can get rid of this information, clean this up. And in fact, this whole thing, just delete it. So we have a nice clean little README file here. And I'm going to say get status to double check everything that's inside of here. We have README changed, get add README, it adding deletion or adding fixes to README, clean up, go, push. Now let's double check also our Docker file here that's inside of dev container, because originally when I set up this template, it was only for GPU based machine learning. So there's a couple things here that probably I don't care about, like GCC probably, let's leave it. I might need that, but FFmpeg I don't need. And then if I look at here, this looks good. And then if we go to, yeah, this looks like probably what I care about. And then these are also the different packages that are installed in my environment. So you can see I've got a lot of nice tools here for dealing with things, especially Copilot, which is a great tool. So yeah, I think this is a good template. So I'm going to go ahead and I'm going to say, I'm going to commit all this. So let's say get status, get add.dev container, and it will push this. So adding input code. So what's nice is that I can just double check that everything works. So I can say make all, which should run this make file here. And probably the only other thing that I would, yeah, so everything works. We have like a nice structure here that people could follow. The one thing that we should probably do is actually add the GitHub Actions workflow. So static pages here, we can get rid of that. So I'm going to clean some of this stuff up. So I'm going to go into, I'm going to say get rm dev container, .github, and say static. Static. So we don't need that. Docker image, we don't need that. Docker image. And then now let's look at the CI/CD and double check it's what we want. So yeah, we want to change this because we want to change this to be the main branch. There we go. But then the rest should be good, which is install all of our packages, lint our code, test our code, format. And you can see here there's some basic tests here, really simple code. So yeah, this is good. We got a nice structure here. Again, I'll just do make all, check everything's good. Going to lint test everything. So now I got a template. Now I'm going to give people this template to code with Python. So I'm going to say get status, get add this. There we go. Adding workflow changes. Rates. Let's go ahead and push this. All right, so this is pretty much ready to go. And the only other thing I can do is I'm going to now get out of here because I don't really need to be in here anymore. And what I can do is I can actually double check GitHub Actions is working. And so it looks like it is here. So if we look at this, it's going to do like testing, linting, all this stuff. I can just click on this icon here to create a status badge. And now people that are going to use my template for programming, they can actually double check that it even works. I mean, I think this is a very crucial idea, is that if you're going to create a template, you better create a GitHub Actions around it so people know you're not creating some garbage system that they're going to build off of. Like if you can't be bothered to get your continuous integration testing, why would someone use your template? But I think this is very good. I think this is a great little template to use. So now that I created the template, so again, I came from the MLOps template to create a Python template, and let's double check here that other people can use it. There we go. Click on that template. So now people can use this and build their own solutions based on it. Now I'm going to build another thing on top, which is I'm going to build this Assimilate Python repo. So I'm going to go to the other Assimilate Python that I had, and I'm going to just rename it. Let's go to this repo, and let's just change it, and we'll call this archive. Right. There you go. We can rename this thing. So we know that this is the old version. And now I can go to the other template I created, which is this Python template. And I'm going to use this template now to create a new repo. And it should be a little quicker now because I cleaned up a lot of the installation steps. So I'm going to say create a new repo, and we're going to call this one a Assimilate Python. Assimilate Python. There we go. And let's say this is a repo using a Python template from GitHub. There we go. Public. There we go. Pretty nice. So we got a nice little environment here. You can see how easy it is to create templates yourself. Okay, next up here, what am I going to do? Well, now I'm going to go really quick, and I'm going to get this code space thing cooking, because this is really, really helpful, right? The pre-builds, because it basically will make things way faster. So that's really the first thing that I would want to do, is always make, when I'm going to be working periodically out of a repo, is to set up this pre-build. Now, again, what's cool about this is that we can see here, I can even watch it get built. It'll probably take a little bit of time, so I probably won't be able to use it for launch, but it is cooking, so that's good. Now, the other thing that I can do is I also can go switch to here, and I can say your workspace in the cloud, and I'm going to say new with options. Again, I'm going to pick a real beefy machine here. I love powerful machines, 16 core. Let's go. So this should be a little bit faster to launch because of the fact that I cleaned up a lot of the installation. Like, the installation packages I had before were just huge. And also I cleaned up the Docker file a little bit. So I believe this should be a little bit quicker in launching. And then, as I mentioned before as well, the other thing that is going to help us, not this time, but the next time, is that this pre-built container will make it so that in the future, when I launch it, it'll launch in just seconds, which is really, really cool. I mean, that's one of the great things about this. So again, we can look at the packages here. The packages, when we install them, should be way quicker, because I deleted so many different packages. It should only have just a few, and they're not like exotic packages that do all kinds of tricky things like compile Python. They should be very, very quick, and I think it's already done, right? So we can see the startup time is just amazingly quicker versus the old one, which had just tons and tons and tons of packages to install. So now it's working on some Debian packages here. I probably could have gotten rid of this, the CUDA toolkit, which is in the dev container, and we can take a look at this. So under here, if we go to dev container, I think I enabled this option, which I shouldn't have, which is this. I can disable that in the future, although I'm using code spaces, so it doesn't really matter. But basically, because I'm not using GPUs, we don't really need this option. And I think that is slowing things down a little bit. But again, I think this is going to be still pretty quick. There we go. And I guess the other thing we could do as well is we could just double check the GitHub Actions. Yeah, it is. So we can change the GitHub Actions badge here, because this is a brand new environment, right? So if we click on it, no, wait, we want to go to Actions, initial commit. No, that's pre-build. So we want to go to continuous integration. and we want to run this workflow real quick. And this should, there we go. The status badge. So that's what I was looking for. So we can go here and we can swap out because it was using this status badge before. So let's make it use the right status badge, like our own status badge for this. There we go. And I also could in the future put a, so let's commit this real quick. I could also create a status badge for the pre-build, which I think is this code space pre-builds. So if we click on this and I click on this, I believe there's a button here somewhere. It's always confusing to me where it'll tell us how to actually set up the pre-build, how to set up the pre-build badge, which is it here? Oh, there you go. Create status badge. That's what I care about. So C says code spaces pre-build status badge. All right, let's go back to here. Now we have two badges. So we're telling people that are going to use our project in the future, because this isn't a template. This is just a repo I'm using that I can do continuous integration, and we also can do code spaces pre-builds. Perfect. This is great here. And if we go back, there we go. We're in business. So this is cool. So we're now ready to write code, which is something I've been waiting for. I'm super excited to now start doing things. So let's do a get pull, make sure we got all the latest changes. We do. Now, in terms of programming with Python, I think what I'm going to do is I'm going to create a I'm going to create code inside of this my lib directory here. So the idea here is that because I've already got my structure set up inside of this project where it's able to lint my code, test it, all this stuff, and refactor it, it should be pretty easy to build up new examples. So for today, what are we going to cover? Well, let's actually make a lessons directory here. So we can call this one lessons. And let's go to the official Python documentation, python.org. And let's see a fun place to start here in learning Python. Let's go to the docs. If we go to the tutorial, we can get some ideas. So here's the tutorial. And I believe control flow, in fact, we've done modules. Let's see, what else do we need to cover? Input and output, errors and exceptions, classes. Let's go into classes. Let's kind of change things up a little bit, and let's go into classes. And I'm going to do this. I'm going to say classes. Let's say official docs. All right. So with object-oriented docs, with object-oriented programming, it definitely is different than functional programming. And I'm going to show you a couple little techniques here that I think are pretty cool. So one of them is that if you want to start off with classes in Python, one good way to do this is to use IPython here. And so if I went through here and I said foo is equal to class, like this, basically I could build out some kind of a class. And if we look at the Python documentation here as well, we scroll through this, one of the things that you can see here is you can say class name to do a definition. So in general, right here, if I again I just paste this in here and I say class, notice how it's camel case like this. So we can call this, I guess, use this, and we can say class name, pass. And now if I type in who, it'll show me that there's a definition, but I haven't made an object of it yet. So what I can do is I can say this, I can say foo class name, that foo is equal to class name. This I think is one of the easiest ways to play around with classes, is to make an empty one and then just put stuff inside of the class. So if I say foo.id equals 1, and if I say foo.name is equal to 2, or let's just say John, now I actually have attributes on this class. So if I say foo.id, right, or foo.name, right, I've got stuff basically built in. I'm building out a set of attributes that are on this class. And in fact, another thing that I can do, and this is a neat little trick that I like to play around with, is if you do dot under dicts, it'll print out the dictionary that contains all of the values for the attributes. So I think this is one of the easier ways to actually build out stuff in Python, is to use IPython and actually to build out some kind of a object-oriented structure. So now that we know kind of the hello world here, what we can do is actually build out some kind of solution. So I'm going to go to this library here, and I'm going to create a file. And what we can do is let's call this a soccer player potentially. So I'm going to say my lib soccer.py, and what we can do here is start building out a object-oriented structure for soccer. So because Copilot is going to allow me to use it to build out basically suggestions, I can even put that inside of here. So I can say, object-oriented soccer player class. Sure, that works, right? So what we want to do is we want to create an object that will contain a class that will contain things about a soccer player. So let's see what it actually gives us for a suggestion. We can say like class player. That looks pretty good. And let's see what kind of suggestions it's going to come up with. Maybe we can, there we go. So you just have to wait there for a second. And we can let it give us a suggestion, and we can take a look at it. So we can see it came up with name, number, position. That looks pretty good. And then it gave us a bunch of helper methods here that we can use, and this is called operator overloading. So it's able to do a bunch of fancy stuff here for us. Now, I don't really want any of it, basically, because it's just a lot of stuff to deal with. So instead, what I'm going to do is I'm going to just get rid of all this. And instead, I'm going to say that's good enough to start with. And then I can start playing around with this. So this is why, again, IPython is so fun, is I can do this. I can say IPython, and I can say from my lib dot soccer import player. I think object-oriented programming with IPython or Jupyter Notebook is actually surprisingly, I would say IPython actually even more than Jupyter Notebook is a very good fit for this style of programming, because now I can do this. I can say player equals player and just make an instance of that class. It says we're missing 3 required positional arguments. So this is something to be aware of when you're doing object-oriented programming in Python. When you see it's got an init here, this means that I can't initialize it as an empty object because it's going to require me to put these other attributes inside. So not a problem. We can change that by filling out these values. So we can say name is equal to and let's just, is it Messi basketball? Yeah, Messi, MESSI. I've seen Messi before in live in the Champions League game in Germany. That was pretty fun. And with the number, I actually don't know what his number is. I'm just going to make up a number, 50, and then we can say position. I also don't know I don't know enough about soccer to know what his position is, but we'll just call this forward. And there we go. So now if I say player dot under dicts, you actually have an example of this. So one of the things that we can do that's kind of fun is that now that I know how to use this, I can create a new terminal here, and I can toggle back and forth, right? So I can have my main terminal, then I have the object-oriented terminal, I think it's typically a good idea when you're doing object-oriented programming to consider building unit tests because they really work well together. And I have a very basic test here, which is just this test main. But why don't we build another one called test soccer? So I'm gonna go ahead and say touch test soccer here. And then what we're going to do is we're going to actually write a test for this class here. And so what I can do is open this soccer test up here, and I can say from my lib dot soccer import soccer imports in this case we want to import player. So player. And then exactly, we want to build a test for the player. And look, here we go. It actually helps us write out a test for us. So this is what's one of the really cool things about using Copilot and this template is that I'm immediately able to write a unit test with the boilerplate code is essentially written for me. And in fact, if I go to the Docker to the make file here, let's double check that we're able to do we're going to test my lib. So all I need to do now is just type in make test. And not only am I going to test my code, but it's actually going to show me the coverage report. So like how much of the library I'm covering. Look, 100% test coverage already. So we're in great shape. So I think between Copilot, IPython, PyTest, and this makefile, this is a great way to start building out stuff with object-oriented programming. And again, we've already got a nice test for this. So what else would we want to do here inside is potentially we could practice a little bit of inheritance. And so with inheritance, the idea is that you inherit from one thing and then build another thing off of this base class. And so we can even have Copilot help us, and we can say like, like extend player class by adding a method that's, I don't know, returns the weight of the player. I don't know. I'm just making this up. And so what we could do is say class um, uh, player stats or something like that. And look, what we do is we inherit from that particular scenario here, and we actually are able to actually make it a slightly different version. So, and maybe we even change it as well. We even say like player um biometrics, maybe would that be, or we could even say player physical attributes, something like that. And so what this is going to do here is that we're basically using all the stuff we already wrote, so we don't have to write it again. And then we're going to um, add another attribute, which is weight, and then we add a method that is able to operate on that particular weight. And so in order to use it again, I would just play around with it. So we would go back to here, and let's just exit out of here. Let's import again. So we can just have Python, say from lib.soccer import player. Go soccer import player. No, actually, we want to import player physical attributes. There you go. So it's going to be the same signature, except for we're also going to have weight. And what we can do here is we can just say player is equal to, we're going to say messy position, but we're going to need to add one other thing, is we're going to need to say weight. And we'll just say messy probably weighs 70. And let's do that. And now we know that that's the wrong name. So it's going to be player physical attributes. Like that. Go. Player physical attributes. player dot dict. Yeah. So now, what is the magic of object-oriented programming? Now I can just call this method that says get weight, and it returns back the weight. And I also could even extend this thing further. So if I wanted to add some other cool methods on here, like for example, um, things I could do is I could say, um, how about like average weight um, by position. And we could say like we could do something kind of fancy, and we could even build in inside of here. We could say positions. No, we could basically go through here and say um, positions is equal to. I think actually we could do this here. It's self dot all positions. That. There we go. So we actually don't want someone to change it, but we do want it to be initialized, like right here, and then we could say basically, there we go. That's exactly. I wanted to do something like that. Um, Now, in this case, this looks like kilograms. And so we can say even a little note here that says returns the average weight of the player by position in kilograms, which seems much more reasonable there. And so then now that we've got this, what we could do is basically we could change this because instead of instead of instead of it being the weight that we set, why don't we actually use this other method here to auto assign this? And so we could, in fact, do something where you do a property. So you could do you could say create a property decorator to return the weight in kilograms based on position. Okay, so we would do that. Don't think weight in kilograms. I think we would want to do more like return. So you would say return. We could actually do this. We could say weight here, and you would say creates that automatically returns average weight based by position. So we would say weight here. That's exactly that's exactly what I would want to do. Is I want to get rid of this weight because we're going to auto assign it here. That now I think it's going to be a lot smarter. And so what a property does is it will calculate, right? It'll calculate basically this value. It'll assume or it'll act like an attribute, but look, it's actually going to use whatever position is actually passed in, and it's going to calculate the weight based on it. So let's go ahead and try this out, which is again kind of one of the cool things you can do with object-oriented programming here. So we say IPython, say from lib soccer players import physical attributes. That looks pretty good. And we can say player is equal to, we can just do, now we don't need weight. Right? We just need to have the name, the number, and the position. Now we do need to match this. I mean, I guess I could clean that up later and make it like lowercase or uppercase, which isn't a bad idea. But let's just go ahead and we'll do this. We'll say forward like that. And now here's the magic of object-oriented programming is that if I do dots weights, there we go, right? So we're able to automatically calculate that weight. So this is one of the really cool things you can do with object-oriented programming is is inherit from another base class that's got some basic things in there, and then add some super fancy things in there like automatically calculate, weight, and then add a property that acts like a regular attribute that is basically a calculation of what it is you're building. So I think that's a very good example of this. Now, if we go back to here and we do the unit test, we're not going to have full test coverage. So we need to clean that up a little bit. There we go. Notice it's only got 50%. So we need to add another test here. There we go. And perfect. This is what's awesome about Copilot is it writes the test for you. A search player object. No, because the import player and then this will be, you have to be on your toes though. I mean, it did do what I wanted it to do, but you do have to be on your toes. There you go. So we're in good shape. So I'm going to go ahead and check all this in. Status, git add, readme, git add all this. Adding object oriented code example. There you go. So you can see you can become an object-oriented programmer extremely quickly by using Python alongside of GitHub Codespaces and Copilot. All right. That's it for me for today, and I'll see you in a couple weeks. I'm going to do this every couple weeks, but a little bit longer. All right. See you soon.